More than half of the world's population currently lives in cities, and that proportion will grow to 2/3 by 2050. And the bigger the cities, the bigger the mess. Already heavy concentrations of trash, wastewater, and greenhouse gas emissions are only expected to rise in metro centers across the planet. To address this, NYU's Mingjin Liu and colleagues used scaling theory to analyze waste products from more than 1,000 cities around the world.
So what is scaling theory? Very easy. Consider a system, a human body, a tree, a city. You can measure the system by size. So scaling deals with how does the property of the system change as you change its size. And basically we found different type of scaling relationship depends on which type of waste we are looking at. We found sublinear scaling of greenhouse gases, super scaling relationship with wastewater, and wrapping between municipal solid trash. On broad stroke, if you double city size, you double the amount of trash.
Crucially, their analysis showed that cities with a higher per capita GDP generate more waste overall. The researchers say that this shows the need to disentangle economic growth and waste generation, and that cities should commit to zero waste goals through recycling and composting, as San Francisco and Seoul have done in recent years. Is it better to scare people into climate action or motivate them with inspirational stories? A new tool created by an international team of scientists aims to provide insights into these questions.
We recruited a sample of 59,000 participants from 63 countries and tested the effects of these 11 interventions on participants' beliefs, policy support, information sharing, and effortful behavior.
The effects varied depending on the participants' nationalities and cultures.
For example, the scientific consensus intervention increased policy support in Romania, but decreased climate policy support in Canada. This result can inform the development of local intervention strategies.
The authors noted that whether optimistic or pessimistic, the responses reveal a consensus regarding the dangers posed by climate change. While scientists agree that global warming today has been caused by human activity, a new analysis shows that periods of climate change millions of years ago were tied to astronomical and geological forces. Research by NYU's Michael Rampino and colleagues showed how massive volcanic eruptions release large amounts of carbon dioxide.
And the amount of carbon dioxide that's released is so large that it produces a tremendous greenhouse effect, much larger than the one we're producing now with fossil fuels. When these volcanoes have gone off, surface temperatures and the surface temperatures of the oceans went up above 42 degrees Celsius. That's a lethal temperature.
These dramatic events aligned with critical changes in the planet's orbit.
Sea level changes, mountain building events, tectonic events, they all seem to be following a cycle between about 26 and 36 million years. Changes in the shape of the Earth's orbit, whether it's circular or more elliptical, has a cycle about 27 to 33 million years.
The alignment between the geological and astrophysical cycles was too statistically significant to be a chance occurrence, meaning the astrophysical affected the geological. So the next time continental flood basalt eruptions lead to toxic oceans and a rapid rise in global temperatures, you can blame the stars. But don't worry, it's not due to happen again for another 10 million years at least. In the meantime, we have enough work to do countering our own human-made climate change. Learn more about this story and all the latest climate research this Earth Month at nyu.edu/news. I'm Jade McLean, and I'll see you next time on Brainiacs.